Now let us try understanding that formula with the help of a small example here. So this is a fuzzy statement. There are about 2 employees in a company who are efficient, and I represents a small sample in the entire set of employees in that company. And if you look at the small table here, the first row indicates all these employees. The second row indicates the efficiencies of these people in a range of 0 to 1. So these are like absolute values. So here, these are absolute. The third one represents degrees of efficiency in F of these values. So why do I have different values in the third row when I compare them with the second row? What do these indicate and what do these indicate? How are the values in row number 3 different from the values in row number 2? I'll give you guys a couple of minutes to understand this. Alright, fine. So here's the answer. So a couple of values here will pretty much help you understand what these values are all about. Now these ones, the values in the second row, this, as I have already told you, are absolute values. So they are sort of like grade values that are associated with people. And if you compare this 0.3 and 0 here, so Mike, if you put him on a scale of 0 to 1, he gets 0.3 as his efficiency value. But when you compare Mike's efficiency value with the rest of the people's efficiency values, he gets a 0. So what's happening here? So technically, there's no one in that company with an efficiency value less than 0.3. So since Mike has the least value, he is now considered as a 0. Another value here, let us look at another comparison with Mira. So Mira has 0.9 in the absolute scale, but when you look at this third row, she gets 0.95. So what does that indicate? She's definitely not 1. So there is someone who is greater than 0.9. It could be 1, it could be 0.98 or something else. But there's someone definitely higher than Mira, but there are not many people that are greater than Mira. And that is the reason she gets a 0.95. So this, if you like put it on a graph like this, and then it goes something like this. So Mira would be lying somewhere here. Yeah, so Mira would be lying somewhere here, and maybe Mike would be lying somewhere over here. So that is what these values are all about. So anyway, so as we have already seen, the truth value is given by Q of mod E. So truth value of the proposition is what we needed to find here, and that is given by Q of mod E. So let us try finding what this mod E is. So mod E is cardinality. If you guys can remember from the earlier classes of fuzzy sets, cardinality is nothing but summation of all the membership values in the set. So these are all the membership values we are looking at, the third row values. So we sum up all of them, we get 3.5. So now we have to find out Q of 3.5. So what's my definition of Q? To find out what this is doing, we need to find out what Q is doing. If you look at the small graph here, this gives you a membership function for Q. Now why is this right, or is it defined anywhere in my question? No, it is not. This is just an assumption. Now if you guys remember the classes about membership functions, the different type of membership functions, all we are trying to do is come up with some random membership function for our fuzzy sets. So with Q here, we are trying to find out a random fuzzy set. So Q is my quantifier. So it says about 2 employees. So my graph should be peaking at 2. That is, at 2 it should give me a value of 1. So in all other places it should have a lesser value. So I could pick multiple membership functions. The first one that comes into my mind is a triangular membership function. So that is the reason I've drawn a triangular membership function for Q. Now since it is peaking at 2, I could like pick a graph like this as well. So even that is right, not saying that's wrong, but still you always want to like bring in as many values into your graph as possible. That is the reason it has been extended to 0 to 4. So anyway, so you could like come up with any graph, but make sure that your graph is peaking at 2. So that is what we are looking at. If I were to like find out what my 3.5 is representing, what I can do is I'll try and see where my straight line is intersecting the graph. It's intersecting at this point, which represents approximately 0.28 on the y-axis. So my final answer Q of 3.5 is 0.28, which is a very low value. On a scale of 0 to 1, you know that 0.28 is very low. So I cannot really trust this particular sentence. So I can say that this is fairly false in another way. So it's definitely not true. So I might need something greater than true, greater than 0.5 in order to say that it is true. Maybe. For that again we need to define our own membership functions. Anyway, I'll try finding out what the truth value is if the statement was there are about 3 employees in a company who are efficient. If that was the case, what would have been the value? So this time around my graph would shift to the right side. Why? Because I want to make sure that it is peaking at 3. So this time around I start at 1 and then I finish at 5. Once again it's up to you guys wherever you want to like start and then finish, but then make sure you maintaining this triangular shape. So my 3.5 lies somewhere over here. So I map this onto the graph and then I see the intersection on the y-axis. This time around I get a very high value, which is 0.75. So had the statement been there are about 3 employees in a company who are efficient, then my statement would have been more truer than if my statement was just about 2 employees in a company who are efficient. So that is the way you find out truth values in the case of fuzzy propositions. This is a small example. This can be extended to other types as well. We have 2 more types in fuzzy quantified propositions. And type 2 proposition looks like something like this. There are Q, E1 and E2. So an example for that would be something like this. In a company of young employees, there are about half of the employees who are efficient. So over here, my quantifiers is definitely this thing. About half is my quantifier. And what are my 2 fuzzy predicates? One is definitely efficient, whereas the second one, if you guessed young, then you're definitely right. Yes. So this is my predicate number 1 and this is my predicate number 2. So if you have statements of this sort, then your truth value is found out by a formula like this. You take a cardinality of E1 intersection E2, and there is another type which goes by Q E1 or E2. So an example for that would be almost all employees are efficient. So here quantifier is almost all, young is one predicate and efficient is another predicate. And the truth value for this is found out by a formula like this. So it is cardinality of E1 intersection E2 divided by cardinality of E1. So you can pretty much extend whatever you have learned in case of type 1 to this type 2 and type 3 and then find out the truth values of your fuzzy propositions. So in this chapter we have one more topic left, then that is linguistic variables and hedges. We're going to look at that in our next video. Thank you.